In August 2019, the Virgo interferometer that detects gravitational waves caught one very unusual collision. Here's what it sounded like. That was a black hole swallowing up another much larger object. It happened 770 million light years away from Earth, and it's something we'd never, ever seen before. One thing is clear. That was some remnant of a dead star that existed on the boundary between known neutron stars and black holes, in the place where nothing except a void is supposed to exist. And although this Object X disappeared forever after the collision, it could change the way we perceive the universe. But where did that gap between neutron stars and black holes come from? How extraordinary could Object X actually be? And what objects do stars turn into after they die? The information that gets into a black hole disappears forever, but the digital footprint that you leave on the internet is never really gone. SayMind.com will help you discover and manage which and how many companies hold your personal data. I signed up to mine with my primary email to find out how many companies hold my personal information. On average, it's 350. I wasn't expecting that big of a number because I'm pretty paranoid and just hardly ever sign up to anything, but even I was astonished to see that my data was in the possession of a company whose name I had never even heard before. However, they have information on my credit card, passport, and phone number, and with the growing number of data breaches every day, I need to make sure my sensitive personal information is not at any unnecessary risk. So, I'll have to ask them to send it all into the black hole. The best way is to make an official reclaim request to the company by email, but for you not to draft it yourself, not to lose correspondence, and accurately control the deletion of data, you best use Mine. Just 2 clicks, and Mine helps me send the company an official request to delete my data directly from my own inbox. If you change your mind, the data deletion can be undone in the first hour. All requests are within a single tab, and you don't need to search for correspondence with companies in your mail. Go to SayMind.com, sign up, and regain control of your personal data. It's certainly easier than trying to erase your digital footprint using a black hole. Speaking of black holes, why couldn't Object X evolve from a regular sun-like star? We know that at first, such a star turns into a red giant, and then it sheds its outer layers and becomes a white dwarf. This is a strange body. Its mass can be compared to that of the Sun, but it's hardly bigger than Earth. There are almost no fusion reactions in it, and its dim light is a star's residual heat. As a matter of fact, a white dwarf is a barely flickering corpse. In one of the simulations, NASA scientists tried to place it instead of Object X and saw that the black hole absorbed it with a flash. However, nothing like this happened when that mysterious collision occurred. What's more, white dwarfs cannot be as massive as Object X. The Chandrasekhar limit is the maximum mass of a white dwarf star, and that means there's no way it can be more than 1.4 times heavier than the Sun. But what if, while searching for Object X, we test this theory and make 2 small white dwarfs crash into each other? That's precisely what happened 7,000 light years away from Earth, in the constellation of Cassiopeia. A couple of 2 white dwarfs produced a bright and very exotic zombie star. Some astronomers compared it with Frankenstein's monster. But eventually, we'll see that the Chandrasekhar limit isn't just a saying, as gravity will compress the stellar corpse and make it even more extreme. And then it really will begin to look like Object X. But why can't remnants of even larger stars and products emerging after collisions between white dwarfs be our Object X? Ridddle, a blue supergiant star, is 17 times more massive than the Sun, and one day it's going to explode as a supernova. but the stellar corpse it'll turn into will be nothing compared to the size of the star. It'll be just 12 kilometers in diameter, and so it will perfectly fit in Jamaica Bay, New York. This object's gravitational force is so strong that it's crushed even atoms. Every atomic nucleus usually contains protons and neutrons. If extremely compressed, elusive electrons go off their orbits and fuse with protons. As a result, there's nothing left except tightly packed neutrons. Now it makes sense why corpses of massive stars are called neutrons. Given this density, a typical neutron star has a mass in the range of 1.5 to 2 suns. As a rule, when it collides with a black hole, there's no visible explosion. That's why astronomers initially thought that Object X looked like a neutron star. Apart from that, they also studied its gravitational waves and calculated its mass, and here lies the main problem. According to the Tolman-Oppenheimer-Volkov limit, a non-rotating neutron star can't be heavier than 2 suns. Otherwise, gravity will take over and squash it into a black hole. In case this object does rotate fast, we can add 20% more of the solar mass. But our elusive Object X is more than 2 times heavier than the Sun. So what is it? Just a small black hole, case closed. It's a shame, but the tiniest of known black holes is 2 times more massive than Object X, since this mysterious stranger lies on the boundary where, as we tend to think, nothing except a void can exist. Well, maybe a void and some even stranger objects whose characteristics resemble that of Object X the most. However, they are hardly more than a theory. What if we try to add some little extra mass to the neutron star? A supernova explosion is unlikely to leave behind a stellar corpse with such characteristics. So, let's go to our space crime lab and try feeding a typical red dwarf to the neutron star. Keep in mind that a dwarf is around 5 times lighter than the Sun. What do we get? According to the laws of quantum mechanics, the neutron star won't be compressed into a black hole at this point, but will shrink even more and turn into a quark star. The force of its gravity has crushed even its neutrons. Each of them has broken apart into even smaller particles called quarks. It's like cramming a few burritos into one little lunchbox. When snack time comes, you'll have to eat some weird mess. But it's still essential to check what quarks the star is made of, as they can be different and also strange. And then we'll get a strange star. And yes, it's a scientific term, although astronomers strongly doubt that such unusual corpses can emerge after supernova explosions. Strange stars have probably formed shortly after the Big Bang and are still there today. Does our Object X belong to them? According to one of the theories, due to their unique features, quark or strange stars can be 2.5 times heavier than the Sun. Now, that's closer to what we're looking for, but let's not leave it halfway through and consider even the oddest of suspects. Could Object X be an exotic star with the most unusual characteristics and mass? The best way to get one of them is to make a neutron star swallow up a small white dwarf. As a result, we'll have an electroweak star whose mass is very close to that of Object X. At first glance, it looks like a neutron star, but its core resists being compressed into a black hole through the so-called electroweak burning. And it gets energy from those very quarks that, under other conditions, produce a quark star. However, it's estimated that an electroweak star can last 10 million years at most, and eventually it'll collapse into a black hole. Although, according to basic principles of quantum gravity, there may be an alternative outcome. This celestial body is very similar to a black hole, but don't let it trick you. You're looking at a Planck star. If a supernova explosion makes energy accumulate in a certain way, the laws of quantum mechanics won't let the stellar corpse become a black hole. At the same time, a Planck star, as well as electroweak and quark ones, turns out to be nearly a perfect candidate for Object X. And finally, here's the last theory, and it gives scientists a splitting headache. Indeed, the black holes that form after supernova explosions can't be lighter than 5 suns, as they immediately absorb a lot of matter emitted by the dying stars. But if some unknown law of physics spoiled the first breakfast in the black hole's life, this also makes it a potential Object X. In fact, all our versions are so bizarre that whatever our stranger really is, it's a breakthrough for astronomy anyway. And not only for astronomy, since many of us contact dead stars daily. When neutron stars collide, heavy metals like gold occur. You heard right. Your jewelry is literally made of blown stellar corpses. In the long run, Object X could emerge this way too, in case, for whatever reason, some 2 small neutron stars released a lot of mass when hitting each other. That's how a previously unseen black hole lighter than 3 suns could be born, together with gold dust sufficient for forming a whole new planet. Who knows, maybe right now you're wearing a piece of Object X on your neck, hands, or ears. Check out this video if you want to learn more about the rarest objects in the universe. There's a galaxy with another galaxy inside of it. How is this even possible?